All right, here we are in chapter 2, section 2, and we are going to be talking about acceleration. Now, first off, I want you to be careful when you hear this word acceleration. Most likely, the thoughts that come to mind are the car accelerated. You think of that as when it's at a stoplight, the light turns green, and the car starts to go. But scientifically speaking, acceleration is defined as the rate of change in velocity. Remember that we have two components to velocity. Okay, so what can we change to have a change in velocity? Okay, we can have a speed change or we can have a directional change. Okay, two ways to change speed, going faster or going slower. So we really have three types of acceleration. Okay, positive acceleration, negative acceleration, and then directional acceleration. Let's start with positive acceleration. This is the one that you guys, when you think of acceleration, what comes to mind? Positive acceleration, scientifically, is acceleration in the same direction of velocity. Okay. For what you guys need to know, it is when the car is speeding up. Okay, when our speed increases. Okay, we're going to be calculating this, so yes, velocity has that directional component, but we're going the same direction, so we ignore that, and our car is just speeding up. So I'm going from 5 meters per second north to 7 meters per second north. Negative acceleration is when acceleration is in the opposite direction of velocity. And again, getting into some vector stuff that we don't need to completely worry about, but you know this as when you hit on the brakes or are slowing down. Again, we're still going in that same compass direction, so we don't have to truly worry about that directional component here. So we are going from 10 kilometers per hour to 6 kilometers per hour. We have slowed our speed down. Final component is directional. I think just by the term, you can figure out that directional acceleration is acceleration that occurs at any time we have a directional change. Okay, car traveling at a constant speed but is turning. Okay, image here is a little misleading, but I think you can figure it out. I can go from 5 kilometers per minute north to 5 kilometers per hour northwest. Okay, my direction has changed. I've curved, but my speed part of it has stayed the same. When we calculate acceleration, okay, the formula can get a little tricky. And remember last week I told you to really make sure that you write your variables down. Here it's going to become increasingly important because we have multiple components here. We now have 4 different variables. We have acceleration as A, we have time, T, okay, in seconds, and then we have this VF and VI. That is our change in velocity. VF is final velocity, VI initial. Okay, it will always be final minus initial. It doesn't matter if it's positive or negative acceleration, you will always have velocity final minus velocity initial. Okay, so let's do a practice problem together. Okay. A driver is traveling east on a road. When she speeds up, she accelerates her car to 17 meters per second from 5 meters per second. in 6 seconds. What is her acceleration? So step 1, again, please make sure you are doing all these steps. I can't figure out what you did wrong if you don't show me your work. So step 1 is going to be identify all our variables. Okay, and you'll have to pardon, it's not going to be the neatest because I'm trying to write with my stylus. Okay, I'm trying to find acceleration, so that's my question mark. Okay, now I need to start looking at components. The easiest thing to identify is going to be the speed. Okay, so 6 seconds. Now I've got 2 more components here. I've got 17 meters per second and 5 meters per second. I need to read the statement and figure out what is my initial speed and what is my final speed. So she accelerates her car to 17 meters per second from 5. So that from tells me that that's the initial. So that means my 17 is my final. Now going over to the triangle, I need A. So I'm going to go A equals BF minus VI over T. Remember, my VF and VI are in parentheses, so when you type it into your calculator, make sure you do that component first. Remember your algebraic order of operations. So I've got my final 17 meters per second minus 5 meters per second over my time, which is 6 seconds. Plug that into my calculator. 17 minus 5 gives me 12 meters per second divided by 6 seconds. 12 divided by 6 gives me 2. And then my acceleration units, meters per second squared. Okay, and the squared only applies to the seconds part. So blowing up this section, different color here. Okay, my acceleration equals 2 meters per second squared. Okay, again, that squared is only applying to the seconds. Okay. So here is one for you to try by yourself. A baseball is hit straight up at 30 meters per second. The ball has a negative acceleration of 10 meters per second squared. How long does it take to reach the top of its path? Please remember to go through each of these steps. Identify your variables, write the formula, and then solve. All right, here's another one for you. During a marathon, a racer slows down from 4 kilometers per hour to 2 kilometers per hour over a time span of 15 minutes. What is her acceleration? Just a little warning before you begin this problem. Please note components here are hours versus here are minutes. Okay, it's going to be a lot easier for you to convert minutes to hours than to try and convert the kilometers per hour to kilometers per minute. Now on to graphing acceleration. Okay, a little bit different, but a lot the same. So please make sure that as we go through this, you kind of compare it back to our graphing speed. Okay, here the x-axis is time. Y-axis now is going to be speed, meters per second. Okay, our slope then is going to give us acceleration. Okay, 3 scenarios, just like from last time. We had our positive slope, our straight horizontal line, and then our negative slope. Okay, positive acceleration is going to be that upward rate slope. Okay, looks like that. Okay, we then have negative acceleration, which is going to be a downward right slope. And then zero acceleration is our flat line. Now remember what zero acceleration means. It means no change in velocity. Okay, last week a flat line meant that there was no speed, which meant that the car wasn't moving. Here, okay, zero acceleration means there's no change in velocity. We can still have speed though. Okay, it just means we are going a constant speed in a constant direction. So here we have a graph showing acceleration, time on the bottom, velocity on the y-axis. This first segment here, okay, that's that positive acceleration. Our green line here is our negative acceleration. Okay. Red line here, okay, our steady speed, no acceleration. The car is still traveling, and if we follow the line over, we can see that that car is going roughly 20 meters per second. Okay, and then we've got this exponential slope over on this side. Don't need to worry too much about that. That is, the acceleration is constantly increasing. The car is gaining speed at a much quicker rate all the time. Okay. If you have questions, please let me know. Please really make sure you understand the formulas and then make sure you are ready for lab tomorrow. Have a great day. Bye.